a final example of being able to utilize the second derivative test to be able to determine concavity. So we now have a transcendental function. So we have this e to the x, x plus 1. And it's asking us to do two things, to find the intervals of concavity and then to find the inflection points. And we're actually going to do those in the reverse order. We're going to find the inflection points first, and then we're going to find the intervals of concavity. First thing we do, step 1, find the critical values of f double prime. And what you're probably noticing is that f double prime is a little bit tough to find because we have to do a product rule. Now let's do this. Let's redefine f at x and distribute that. And let's just rewrite it as x e to the x plus e to the x. So we're just distributing that e to the x to make it a little bit easier to use. To find f prime of x, we're going to have to use a product rule on this animal. And so little f is x, little g is e to the x, f prime is 1, g prime is e to the x. And a very common error that students make is that they take the derivative and they write it like this. They're going to say that f prime of x is going to be equal to f prime g, fg prime. So that's going to be 1 times e to the x plus x e to the x. And they're almost correct, except we can't forget that there was another term in the original function. So we still need another e to the x. And notice we can simplify this. Notice we can write f prime of x by combining like terms as 2e to the x plus x e to the x. Now we need a second derivative. Now we know the derivative of 2e to the x is very easy. That's 2e to the x, right? But once again, we're going to have to use the product rule on this guy right here. So f is x, g is e to the x, and not surprisingly, just like we got a moment ago, we're going to get 1 and e to the x as the respective derivatives of each of those products, or each of the factors. F prime g, fg prime, so that's going to be 1 e to the x plus x e to the x. Notice that we have 2 e to the x, 1 e to the x. So finally, our second derivative is going to be 3 e to the x plus x e to the x. And what do we have to do? We have to set that equal to 0 because we're looking for the points of inflection and we need the critical values. So be careful. Trying to find this derivative is not necessarily easy. There's a lot of bookkeeping in when we're finding this. We're going to factor out an e to the x, and that's going to leave us with 3 plus x is equal to 0. We're going to set each of these equal to 0. The second of the two equations is easy to find. X is equal to -3. And then to solve this, we're going to take the natural log of both sides. But as we've seen a lot of times, is that whenever you take the natural log of 0, it's not defined. And so that means that this entire factor contributes nothing to the solution of the second derivative critical points. And so the only point of inflection, all right, or the only critical value is going to be this -3. All right, so right here, this is our inflection point. Right? Similar to up here, remember in this previous problem, these were our inflection points. Right? So just to make you aware, because it did ask us to identify any inflection points. Inflection points are essentially when the second derivative is equal to 0. All right. Now we're going to make a sine chart, and this is an easy one because there's only one number, -3. -4 is to the left, -2 is to the right. And I'm just going to stick negative and positive infinity in here. And we are just going to shove -4 and -2 back into the second derivative. And the second derivative is right here. Right? So we're going to get f double prime at -4, and we're going to get f double prime at -2. So over here, we have 3e to the x plus xe to the x. That might be the easiest one we have. So that's going to be 3e to the minus 4 plus negative 4e to the minus 4, which is going to be equal to opposite of e to the minus 4. And we don't know what that number is unless we use our calculator approximately, but I've stressed it a few times and I'll stress it one more time. We don't care about what the actual number is, we care about the sign. And notice this is clearly less than 0, so we can say that the function is going to be concave down. What about negative 2? Well, that's going to give us 3e to the minus 2 plus negative 2e to the minus 2, which is going to be equal to positive 1, since we have 3 minus 2. So that's going to be positive e to the minus 2, clearly greater than 0, right? And remember, just because the exponent's negative, that doesn't mean the value of the expression is negative, all right? Remember, we can write this as 1 over e squared. We can write this, e to the minus 4, as negative 1 over e to the 4th, all right? So it's clearly less than 0. And this is clearly greater than 0. Okay, so this is concave up, and now we're done. So this function is concave up from negative infinity to negative 3. And I'm sorry, it's other way around. It's concave down. Okay, so it's concave down. Since all the second derivatives are negative, and it's going to be concave up from negative 3 to infinity. All right. So hopefully that illustrates fairly well how to go through and use the first derivative and second derivative tests. Of course, you want to use your calculator to verify the answers. But unfortunately, being able to use the calculator doesn't always help you with those transcendental functions, like your natural logs, your e's, your sines, your arcsines, etc. So hopefully this can help you to be able to understand how powerful calculus is in being able to find those points of inflection, increasing, decreasing, as well as the maximum, minima, and concavity.